So section 4.4 takes what we just did the last section, solving systems using matrices, and combines it with something that we actually did last unit, being able to write systems of equations given story problem examples. So there's actually nothing new being taught this section. We're just going to practice two old skills and put them together. So to help us do that, I have a story problem here. We have Mickey, Minnie, and Goofy having lunch together at a restaurant that serves pizza, breadsticks, and soda. We have Mickey ordering 2 pieces of pizza, 3 breadsticks, and 1 soda for a total of $11.70. So that feels like it's going to be something important. So I'm going to underline all of that so I know what's going on with Mickey. Next we have Minnie, and she ordered 1 piece of pizza, 1 breadstick, and 3 sodas, and paid $6.85. So I know that's going to be my second important chunk of information. And then we have Goofy, who spent $19.40 on 3 pieces of pizza, 5 breadsticks, and 2 sodas. Now I always underline like this when I'm doing story problems. It's a good habit to get into because it just helps us really focus in on where that important information is, and that's going to help us be able to write these equations. Now the last thing that I focus in on always is what I call the big question, and that's what I see at the end. We're going to set up and solve a system of equations to find out how much each menu item costs. Now I focus in on that big question because that's what tells me what my variables are. Because if that's what I'm being asked to find, obviously that's the thing I don't know. So I'm going to have my 3 variables coming from those 3 menu items that we're talking about. Pizza, breadsticks, and soda. But I want to be specific about that because I can't just say pizza because I could be talking about how many pieces of pizza, I could be talking about the cost of pizza, I could be talking about how many pepperonis are on the pizza. I don't know if I'm not specific. So this problem's asking about cost. So I know my variables are going to be the cost of pizza, cost of breadsticks, and then the cost of soda. The 3 things I don't know about this scenario. So now that I have my variables, I can put those together into my equations. Now, a tip that I always use when I'm trying to write my equations, besides just looking at what I underlined, is to also look for totals. If you can find a total, it's a pretty good guess that that's going to be where one of your equations comes from. So looking through the problem, the first total I see is $11.70, which is I know the total that Mickey paid for his meal. So we're going to write an equation for Mickey. So I know it's going to equal that $11.70, and I can use all of that information that we have about his order. That there were 2 pieces of pizza, so 2x, he got 3 breadsticks, and then 1 soda. So you can say 1z or just write it as z. So I know that's my first equation. Now the next total I see is going to be Minnie's total. So we need an equation for her. She only ordered 1 piece of pizza, 1 breadstick, and 3 sodas. And she paid that total of $6.85. So there's my second equation. My last one's got to come from Goofy then. That third total I see, $19.40. He paid that for 3 pieces of pizza, 5 breadsticks, and 2 sodas for that total of $19.40. So together, these 3 are the system of inequalities that system of equations that we are working with. We are able to get that from the story problem just like we did last unit. So that's nothing new. That's just bringing back those old ideas. Now, I have a system of equations. We're going to solve that the exact same way we just did in the last section by setting up a matrix equation, finding our inverse, and then being able to use that to answer our question. So based on what we did last section, I know the first thing that I have to do with this system is turn it into a matrix equation. So I'm going to grab all of my coefficients. So a 2, 3, and a 1, a 1, 1, and a 3, and a 3, 5, and 2 for my coefficient matrix. I need my variables of x, y, and z. And then we need all of those answers or those constants for our third matrix. All right, so everything's set. We can actually start thinking about this, plugging into our calculator. So we're gonna make it so we've got some room to do that here. So remember, staying consistent with your calculator makes it so you're always doing the same thing every time. So that means I put this matrix in as A, and I put this matrix into my calculator in B. So I've already done that. So my calculator is set for the matrices. So I know the first thing that I'm going to need is an inverse matrix, so I can undo this piece. So that's what I have in A already. So I'm going to call A, and I need to find the inverse of it. And I get all those messy fractions, which I know I don't want to deal with. So I'm going to use that math button and fraction to turn everything into the fractions that I actually want to be using. So I know that inverse is what has to go into my equation now. So I need to multiply that on the left side of both pieces of my equation. So I need to copy that matrix in here. So we're going to copy our inverse that our calculator gave us, so we can be showing all of our work as we do this here. So there's my inverse that I know I am multiplying on the left side of this first equation. So I'm going to quick fill in the rest of this left side. And then because we are working on an equation, I know everything has to stay balanced, so I've got to do the exact same thing to the other side. So we need that inverse again. So I'm going to copy all of the pieces. I know it feels tedious, but our calculator is doing all the thinking for us. The least we can do is record all of the thinking and write it down. And then the second half. Now remember, it is really important that that inverse is what comes first on both sides of the equal sign. Because if I was to switch this and just stick my inverses on the ends, well, my dimensions aren't going to work anymore. Because if I would switch these, I would have this 3 by 1 matrix times a 3 by 3 matrix. And those insides don't match. So this multiplication that I know is about to get me my answer wouldn't work. So make sure inverse is on the left side, and then we can actually be thinking about our multiplication. So let's get down to our next line here. So on this piece, well, I know that we're going to end up with the identity because we are taking a matrix times its inverse. So we have an identity times our variables. Then on this side, we know we need to use our calculator to help us get there. Remember, if you put the matrices into the same spot as I did, we can always just have A inverse times B. That's the ticket for our calculator on this side of our equation. So we can end up with our answer. So that's exactly what I'm going to do in my calculator. I'm going to pull up my matrix menu, call A, but I need the inverse of that. Then we're going to multiply my second matrix B. Once I do that, I've got my answer. So I have a 125, 275, and 95. But I know I don't want to leave my answer like that. I also know I don't want to leave my answer as a coordinate point because this is a story problem, so we have to be thinking about the context of the problem. We have to answer that big question that we got asked way back at the top of this problem. So looking at this, we know that this is telling me that the pizza is going to cost $1.25. Your breadsticks are going to cost $2.75. And then soda is going to cost you 95 cents. So this is the piece that we are looking for an answer. Just like last unit, don't leave your answer as a coordinate point. Just like any story problem, make sure you put it back into the context to be able to get that final answer. So if we look at everything we did, there's really nothing new. Creating that system from last unit and then solving with our matrix equation to get down to the final answer, just like we did in the last section.